Hello students, how are you all? I hope that you all are good. As we know, we are successfully finished the first lecture of motion in a straight line chapter. So in a previous lecture that we have discussed about vectors. Okay, so what is vector? What are the types of vectors? Okay, and what is unit vector and what is null vector? What is the formula for unit vector? Okay, so what are the rules for null vector and all these things that we have discussed in a previous lecture. Right. So in this lecture today that we are going to discuss about finding the angle between two vectors and the concept of a parallel shifting of vector. Parallel shifting of vectors. So this is a small lecture. Maybe it takes 10 to 15 minutes, but it is a useful concept. Okay. So my name is Rakesh Sir. Welcome to our beautiful physics channel, Rakesh Sir Physics. Right. Shall we start the lecture? What is the chapter going on? Motion in a plane, motion in a plane, and this is a class number 02, class number 02. La 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 la. Okay, right. What is the today's concept? Today's concept is a parallel shifting of vector. Parallel shifting of vectors. Okay, right. So have a look. Parallel shifting of vectors means when a vector is displaced parallel displaced by itself, then its magnitude its magnitude and the direction and the direction does not changes. Are you getting? So what is the meaning of parallel shifting of vector? Whenever a vector is displaced parallel by itself, then its direction and the magnitude never changes. Right. So what is the meaning of vector? A physical quantity having both direction and magnitude. Such type of quantities are called what? Vector quantities. What is the symbol of vector? In a previous lecture I told you that. So this is the symbol of a vector. We can represent with an arrow. So this straight line is called what? Tail. What is it represents? It represents magnitude. It represents what, ma? Magnitude. And this arrow symbol is called what? Head. This is what, ma? Head. What this head represents? It represents direction. Okay. So according to this concept, parallel shifting of vectors. So what is a parallel shifting of vectors? Is whenever a vector is displaced by itself, its direction and magnitude. Its direction and magnitude does not changes. Have a look. Let us see one example. I'm taking a vector a bar and the vector is like this. Okay, this is a bar vector. And this a bar vector is displaced by itself. Have a look. Initially, the position of vector a bar is this, and after some time, it is displaced by itself. And now, this is the new position of the vector a bar. This is the new position of the vector a bar. Have a look. The magnitude of vector a bar does not changes. The magnitude of vector a bar does not changes. And the direction of the vector a bar. Have a look. At this place, this is the direction of vector a bar. At this place, this is the direction of vector a bar. So both directions are what? Same. So this is what? Let us say this is a b bar vector. After shifting, it becomes b bar. Let us consider. Now this b bar vector again shifted by itself parallelly. So what happened? Have a look. This vector is displaced parallel by itself. And this is its new position. Let us say c bar vector. Have a look. This magnitude does not changes. This b bar vector is moving in this direction. This c bar vector moving in this direction. Have a look. Have a look. This is the new direction of the two vectors. So in the concept of equal vectors, I told you that whenever the two vectors are having the same magnitude, also having the same direction, then the two vectors are called what? Equal vectors. Then the two vectors are called what? Equal vectors. So that means from this condition, a bar vector is equals to b bar vector is equals to C bar vector. That means these three vectors are what? Same, equal vectors. That means whenever the vector is displaced, let us consider x is the displacement. A bar vector is comes from this point to this point. Its magnitude and direction does not changes. Then if it is a bar, this is also a bar because these two are what? Equal vectors. Are you getting? Right. So a bar is equals to b bar is equals to c bar. Are you getting, ma? Any doubts? Okay. Right. Next concept I am going to take up finding the angle between finding the angle between two vectors. Finding the angle between two vectors. So to find the angle between any two vectors, we have to follow two rules. Okay, the first one, have a look. Rule number one: always we must take an angle between head, tail, and tail of the given vectors given vectors. So whenever you are taking the angle between two vectors, you must take whatever the angle between two heads, head and head, or you have to take tail and tail. Okay, you never take the angle between head and tail, and you should not take the angle between tail and head. It is not a proper angle. Always you must consider the angle between two heads or two tails of the given vectors. Are you getting? Right. This is a rule number one. So have a look. Rule number two. The rule number two is the angle must be the angle must be in between the angle must be in between 0 degrees to 180 degrees. The angle must be in between 0 to 180 degrees. Okay, example problem. The diagram is like this. They are given the two vectors, a bar vector and the b bar vector. The angle between them is given 60 degrees. Okay, so the question is this: find the angle between find the angle between a bar and b bar vectors. This is the given question. Okay, so whenever we are dealing with this type of questions, okay, finding the angle between two vectors, we must remember two rules. First rule: we have to take the angle between head and head or tail and tail of the given two vectors. Second one: the angle must be lies in between 0 and 180 degrees. These two rules we must remember. Okay, right. I'm going to do the solution by using two rules. Solution. Have a look. Here, this is the A bar vector and this is the B bar vector. This is head and this is head. Now they are given angle between two heads. We always take an angle between head and head or tail and tail. So here we have two heads, head to head exist. Head to head is exist. Angle between them 60 degrees. Angle is how much? 60 degrees. Angle is equals to 60 degrees. Second rule: this angle must be lies in between 0 to 180 degrees. Have a look. 60 degrees is greater than 0 degrees and less than 180 degrees. Therefore, this angle is exist. Now, what is the answer? Our answer is what? Answer is the angle between A bar and B bar vectors is how much one? 60 degrees. Is what? 60 degrees. खत्म हो गया. Any problem? Let us see the second example, and they are given the diagram like this. Okay, this is a A bar vector. This is a B bar vector. Find the let us say this is a 120 degrees. Find the angle between A bar and B bar vectors. So this is the given question. Okay, so pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. Okay, So pause the video and write this part. Pause the video and write this part. 3, 2, 1, go. Right, have a look the solution. Okay, so this is a given diagram, a bar vector and this is a b bar vector. Okay, so angle between them is how much? 120 degrees. What we have to find? We have to find the angle between a bar and b bar vector. Right, whenever finding the angle between two vectors, what we have to do? We have to follow the two rules. First rule, we have to take an angle between head and head or tail and tail. Have a look. This is a head of the a bar vector and this is what? Tail of the b bar vector. So head and the tail. So angle does not exist. Angle does not exist. Then how to find the angle between them? Think, think to find the angle between a bar and b bar. How can you find? By using the parallel shifting of vectors. The parallel shifting of vectors. In a parallel shifting of vectors, I told you that whenever the vector is displaced by itself, its magnitude and direction does not changes. Okay. So by using parallel shifting of vectors, by using the parallel shifting of vectors, shifting I am shifting a bar vector. I am shifting which vector? A bar vector. Have a look. This is the a bar vector. By using the parallel shifting of vectors, I am just shifting a bar vector like this. So now this is what? Shifted a bar vector. What is that? Shifted a bar vector. Have a look. Whenever the vector is displaced parallel to itself, its magnitude and direction does not changes. Okay. Now we can find the angle between a bar and b bar vector. Have a look. This is a bar vector. This is b bar vector. These two are what? Tails. These two are what? Tails. Now angle between tail and tail is exist, but the angle is changed. But the angle is here not a 120 degrees. Another angle is exist between a bar and b bar vectors. What is that? Have a look. Angle between a bar and a bar vector is how much? Have a look. This angle is how much, ma? This is 180 degrees. This is how much? 180 degrees. This angle. Okay. The angle between old a bar vector and a new shifted a bar vector is how much? 180 degrees. Have a look. This total angle is 180 degrees. From here to here 120. So remaining angle is how much? 60 degrees. Now the angle between a bar and b bar is how much? Angle between a bar and b bar vector is equals to how much? 60 degrees. And this is the answer. Are you getting any doubts? Right. Have a look. We will solve one more example. Example number 3. At this time they are given a diagram like this. This is a bar vector and this is a b bar vector and the angle between them is 150 degrees. They are asking find the angle between a bar and b bar vectors. Find the angle between a bar and b bar vectors. Okay. Pause the video and try the solution. 3, 2, 1, go. I will give you the answer. You will get the answer is 30 degrees. Okay. Now pause the video and try the solution. 3, 2, 1, go. I am going to solve the solution. Right. Have a look. Here we have head of the b bar vector and the tail of the a bar vector. Angle between head and tail is 150 degrees. Head and the tail angle does not exist. Then what we have to do? We have to use the parallel shifting of vectors. Parallel shifting of vectors. Have a look. So this is a given b bar vector and this is given a bar vector. Angle between them is 150 degrees. By using the parallel shifting of vectors, have a look. I'm just shifting the b bar vector. I'm just shifting the b bar vector. Whenever the vector is shifted or displaced parallel to itself, its magnitude and direction does not changes. Have a look. Its magnitude and direction does not changes. Have a look. Now the angle between b bar vector and a b bar vector. Okay, so old b bar vector, newly shifted b bar vector, how much? 180 degrees. From here to here, angle is how much? 150. Total angle is 180. Now remaining angle, if you want to find the remaining angle, you have to subtract 150 from 180, because total angle is how much? 180. This much of angle is how much? 150. So remaining angle, total minus this 180 minus 150, how much? 30 degrees. That's it. Have a look. This is a tail of the b bar vector and this is a tail of the a bar vector. Now the angle between two tails, angle between tail and tail exists, and the angle is how much? Theta is equals to 30 degrees. Now, this 30 degrees is lies between 0 to 180 degrees. Therefore, the angle between a bar and b bar vector is how much, ma? 30 degrees. Are you getting? Any doubts? Right. Okay. So pause the video and write this part. I'm going to rub this part. 3, 2, 1, go. Right. So let us see the fourth example. Example number 4. Find out the angle between a bar and b bar vectors. Okay. Right. Now the diagram is like this. This is a bar vector and this is a b bar vector. So angle between them is equals to how much? Right. So solve the solution. Easy one, ma. Easy one. Easy question. So what is the angle between a bar and b bar vectors? First rule, we have to take an angle between head and head or tail and tail. So here we have tail of the a bar vector and tail of the b bar vector. Now the angle is exist. So there is a tail and a tail. Angle is exist. What is the angle between a bar and b bar vector? These two are perpendicular to each other. Theta is equals to 90 degrees. So 90 is lies between 0 to 180 degrees. Are you getting? 90 is less than what? 180 degrees and it is greater than 0 degrees. Therefore, theta is equals to 90 degrees. Are you getting? Right. So, let us see one more example. Example number 5. At this time, the diagram is like this. This is a bar vector and this is a b bar vector. And this time they are given now. This is c bar vector and this is a d bar vector. Okay, here the angle is 30 degrees and here the angle is 60 degrees. Here the angle is 90 degrees. Okay. Right. So find out. Question is this. These are the tails now. Find out the angle between the angles between a bar and the b bar. A bar and b bar. First one. Second one. A bar and the c bar. A bar and the c bar. Third one. A bar and d bar. A bar and d bar. Fourth one. C bar and the d bar. Okay. So this is the given diagram and they are asking to find the angle between a bar and b bar, a bar and c bar, a bar and d bar, c bar and d bar. Okay, right. This is your homework problem. Okay, so try it once. So this is the end of the today's lecture and this is a small concept. Okay, I hope that you are enjoyed this lecture and you are understood this lecture. Okay, so we will meet on a next lecture, that is addition of two vectors, part 1, head and tail method. Okay, this is Rakesh Sir signing off. जय हिंद।